Namaste all dear viewers. In this video I am going to explain proof of triangle inequality of two complex numbers. Here it goes. If Z and W are two complex numbers, then absolute value of the sum of Z and W is less or equal than sum of the absolute values of Z and W individually. Let's get started. So here I start with square of the sum of the absolute value of Z and W. So I take here square of absolute value of Z and W, and that we can write as Z plus W into Z plus W whole conjugate, and it follows by the property Z absolute value square equals with Z into Z conjugate. And after that we go with next one, so Z plus W, and now this Z plus W conjugate, right? So this we can break as the sum of conjugate of Z and W individually. So here you write Z conjugate plus W conjugate, and it follows by the property Z plus W conjugate or whole conjugate of Z sum of Z and W that equals with the sum of the individual conjugates of Z and W. And after that we expand it, we open it, so Z into Z conjugate plus Z into W conjugate plus W into Z conjugate plus W into W conjugate. And now these two, right, Z and product of Z into Z conjugate and W into W conjugate, so that can be replaced back with square of the absolute value of the Z and W, right? So this we write as Z absolute square and the W absolute square. And for this we make here this change, Z conjugate I keep front and W I keep it back for this second one, right? Now and this followed by the property Z into Z conjugate equal to square of the absolute value of Z, and Z into W equal to W into Z. So with these two properties we did that. And now Z conjugate square, square of Z absolute value and square of the W absolute value keep together, and these two, right? So Z into W conjugate and plus now this one, right? So there is Z conjugate and W we can replace with the double conjugate of W, same, and it follows by the property if we make double conjugate of any complex number, then it results the same complex number. And now square of Z absolute value and square of absolute value of W and plus Z into W conjugate plus, and this I will write as this whole Z into W conjugate whole conjugate, right? So I did what over here, Z uh, into Z conjugate into W double conjugate. It can be rewritten as Z into W conjugate whole conjugate. So that I've done here. And after doing this, right, now we do have here another one property to use, right? So it's the real part of Z is half of the sum of Z and conjugate of Z, right? So it gives us twice of real part of Z is equal to Z plus Z conjugate. And by following this thing, what we can do here is we can apply this property, sum of these two uh, terms, right? So what will be that, see, so Z into W conjugate plus Z into W conjugate double conjugate, right? So for this we can write down it's 2 times of real part of z into w conjugate. So what I've done here is it this I have taken as the whole one complex number, is it? So z into w conjugate and conjugate of that z and w conjugate, is it? That equals with the 2 times of the real part of z into w conjugate. So z conjugate square plus, sorry, z absolute value square plus w absolute value square, and plus this is 2 times of the real part, 2 times of the real part of the z and 2w conjugate. And for this reason we do have this with this property we have applied that. And after having that thing, now what we go next is real part of z. Real part of complex number z is always will be either equal or lesser, is it? Lesser or equal with the absolute value of z. So with this property we can say here we can create here an inequality. So this is lesser or equal than uh, z absolute value square plus w absolute value square plus 2 times of real part of, is it 2 times of the z into w conjugate absolute value, or absolute value of the z into w conjugate. So we got this, is it? We got this z plus w absolute value square is less or equal than this thing, is it? And now we will use another property here. This property with this property we did this, is it? And now z and w conjugate, it absolute value of z and w conjugate we can get split in this. So z plus w absolute value square, or we say here uh, z absolute value square plus w absolute value square plus 2 times of z absolute value into w absolute value, is it? For this what we have done here is the property z into w absolute value equals with the product of their individual absolute values, so that we have used here. And after having that much, now we go another step. So square of this is less equal with z absolute value square plus w absolute value square plus 2 into z absolute value into w absolute value. And for this reason is w absolute value, is it is equal with the w conjugate of w absolute value, is it? So equal with the absolute value of w, right? So sorry, so z plus w absolute value square less or equal than z absolute value plus w absolute value whole square, is it? Now with removing the square we get here z plus w absolute value is less or equal than z absolute value plus w absolute value. So this completes the proof.